Hello everyone, it's Nono here one more week, and I want to welcome you to this live stream on creative AI and coding. For those of you who don't know me, I'm Nono Martínez Alonso. I'm a creative technologist and an AI researcher, and I conduct this live stream and also host the Getting Simple podcast. I would invite you to subscribe and click on the bell if you're going to get notified when I go live next or when I upload new videos. And remember that I try to always upload timestamps to the video so you can jump to the most interesting parts and skip the boring ones. And yeah, give me a thumbs up if you want to see more videos like this and if you would like to show, for me to show up every week and upload more tutorials. All right, so I would also invite you, if you're not there yet, to join the community at nono.mas/discord. And I would, yeah, let's see what are we gonna do. Let's see what we're gonna do today, right? I have here two topics. One is fine-tuning Stable Diffusion, and another one is taking a look at image diffusion things. And kind of like a commentary there. I am building this course, some introductory course on let me see if I can, well, I think I'll have to close it, but yeah, on image diffusion models and image generation models in general. I might show some of that stuff because basically I'm gathering a set of slides and information about all of this, right? About Stable Diffusion, image diffusion generation models, how to train them, different model types, etc., etc. All right, so let's get started. Without further ado, I'll do an intro and then we can continue. Hi everyone, it's Nono here, and this is an introduction to fine-tuning Stable Diffusion models with something called Low-Rank Adaptation for efficient Stable Diffusion fine-tuning. This is what's called LoRA. It's a method to train Stable Diffusion models that is faster, requires less computing resources, and also yields smaller train weights, which actually is a big breakthrough because before models were really big, and now you can share models with a little file that has your fine-tuning weights that is around 3 or 4 megabytes, at least when this was made. So we'll see how that turns out, and I would love if you tell us on the chat if you were able to fine-tune any model after watching this or the next videos. I don't know if we'll complete the exercise today, but that's the idea. If we can't, this requires different steps like preparing the data set and actually training and finding the code to train. So yeah, let's get started. Let's get coding. All right, let's get started here with coding or looking at some of the documentation. Let's go here. All right. So the information, what I was mentioning before, actually, so if I quickly show you that slide deck, I have here, let me open this so you get an idea. I have here a lot of content that is still stub content. Let me actually just go through it. Let's actually go through my work in progress slides as well for image diffusion models. So I want to talk a bit about a brief history on image generation, pick to picks here is Carl Steinfeld with some of his experiments. StyleGAN also then do a deep dive in image diffusion, all the different model types. I have some information that is from the web and other information that is actually from ChatGPT. I think I found it really nice to clarify certain concepts and things. And yeah, so I have like I was looking at the different breakthroughs or like different networks architectures in like DALL-E versus DALL-E 3 and different examples. You can see these slides are super ugly. I mean, I just copy pasted things in Keynote to make sure that I don't miss anything. But yeah, this will this will change. So let's see, is there more here? Okay, yeah, so we have here the concept of latent diffusion models, the difference between that and Stable Diffusion's DALL-E and Imagen by Google, the original latent diffusion models paper, the architecture of that paper, then what that paper could do, like text to image and in-painting tasks, then Google Muse, which is not a diffusion model, I think is more efficient than diffusion autoregressive models, different ways. And yeah, I'm trying to see here the architecture of the model. So I'm trying to basically see what the differences are in with different types of models and how they work. Google Muse works pretty well, and they even allow interactive editing. Muse is an open source implementation of that one. Some more stuff here.
Generating image.
Not gonna play that. ControlNet. Then Stable Diffusion. I'm kind of like going through many of these things, and then LoRA, find stuff, blah blah blah, and clip. All right, so that's that's the slides, and we need to work on them a lot because I still don't have a fully good understanding. All right, so we did the intro. This is actually fine-tuning with LoRA. I'm going to get started. So I have a link here. We're gonna take a look at different sources. So here, this is replicate, fine-tuning Stable Diffusion. You can fine-tune Stable Diffusion on your own images to create a new version of the model that is better at generating images of a person, object, or style. For example, we fine-tune SD, so Stable Diffusion XL, on Apple emojis, the Barbie movie, Tron Legacy, and Apple Vision Pro. So let's actually jump and take a look at that one. Let's see what. That link is broken. All right. Let's see Apple Vision Pro. Right. All right. A photo of a bird. Let's see. This model runs on an NVIDIA A40 GPU. Prediction typically completes within 68 seconds. The predict time for this model varies significantly based on the inputs. All right. Yeah, so I mean, these models are not fast. They are pretty big. This can take a bit of time, blah, blah, blah. Booting, okay. Types of fine-tune. There are multiple ways to fine-tune Stable Diffusion, such as Dream Booth, LoRa's, and texture inversion. All right, so I'm actually gonna put some of this information into my slide deck. Come on. And for those of you who are watching live, I planned on making a video tutorial on this, like when all the content is clear, when I have all the steps and all that stuff. Right now, this is a work session. So even though the video says fine-tuning Stable Diffusion, this is a work session where I can attract people through that title and that thumbnail to this video so they can find the other tutorials. But my intention is to make like a more concise tutorial that we can share with a larger audience. All right, so this thing is also gonna go here. All right, so types of fine-tune, and I hope you can hear this properly. Each of these techniques need just a few images of the subviewer style you're training. You can use the same images for all of these techniques. 5 to 10 images is usually enough. That's, that's crazy, I think. That just with 10 images you can fine-tune a model. That's really crazy. All right, so actually I'm kind of mixing because we have today's slides with that. So that says 510 images. It's pretty cool. All right, we care about LoRa's here. So faster to tune, more lightweight than reboot, as small as 1 to 6 megabytes. They're easy to share and download. So again, I'm adapting here. Oh, this is Hugging Face LoRa. Gonna update my URL. All right. Yeah, so this I think is the same repo that we saw last week. Yeah, on fine tuning with LoRa's, the latest news from February 2023. Support for training in painting on LoRa PTI using flag training painting with an in painting Stable Diffusion based model. All right. LoRa joining. V says on the chat here, let me pop out the chat. Closed it. And where are you, chat? Okay. Yeah, and thanks a lot. I mean, thanks a lot for joining. I think it's pretty cool. You're showing up consistently, and that's nice. Where is this? All right, V says, do you have any Colab notebook where I could play with Stable Diffusion? I wanted to try creating some with historic figures. Some image models won't allow to do that, I guess. Yeah, so let's see. Let's take a look at how we can use Stable Diffusion to generate images even without having any setup or anything. We can do it directly on Hugging Face. You can actually go into Hugging Face. Let's actually go to just huggingface.com. We can look for Stable Diffusion. And let's look for 1.5 from Runway and 1.0 base from yeah. So I'm gonna post these links here. I'm putting these links on the chat, on the live chat. And the thing here, so you were talking about historic figures. So for example, we can write here, let's see. Napoleon riding an electric bike in Paris. Let's compute that, and actually we can put that also in Excel base 1.0. So yeah, let's see if that works. Sometimes these models take more or less, but I've experienced that it's pretty fast if you do it with 1.5. Usually, not sure what's going on lately. All right, there you go. So yeah, I mean, I guess like this gives you plenty to play, and you can actually put like animated rendering, movie, Disney, Pixar, or something like that. Let's see if that changes anything. And 1.5 is taking a bit longer. Okay, yeah. um I guess that works. If I bring this to ChatGPT, the quality change is impressive. Let me open a few different ones. All right, so this is ChatGPT, and I'm just gonna put this prompt into different agents that I have on the default. There you go. Try Fidel Castro. Oh, I also thought about Napoleon. Ha. Yeah, I actually couldn't come up with better ideas. Do you have other suggestions? So you said Fidel Castro. Let's try with Stable Diffusion. Fidel Castro. And this one got an error here, but I wanted to see with Stable Diffusion 1.5 as well. Yeah, I mean, this one is not great now that we have other alternatives, right? Okay, so let's go back to here, and in the section of a Stable Diffusion, I'm gonna put like a little section of like exercise, and let's say generate images with the following online services. Exercises. And there you go. Okay, so that's wow. This one worked really well. Okay, I used to do this more, but now I'm not doing it that much. So I'm gonna actually save this the things that we generate during a stream. All right, yeah, and you can see how good uh, ChatGPT is. This might be protected by copyright, but I have an agent that adds this styling to all my images, and it's pretty good. This one's really good as well. Yeah, ChatGPT is pretty good. Turn the character is now Fidel Castro. Yeah, so V is saying, you see, sometimes it tells me that I cannot make it, but then it does it in others. So let's see if we use euphemisms. Yeah, so V on the chat is commenting that they wanted to try on Google Colab Pro, as it would provide some good amount of control. I mean, it's great that you have Colab Pro. Yeah, I mean, I guess they're, oh, this one is really nice. We can see, okay. Great. Okay, so we got some fun if you have other things, but as you can see, these models work so much better than what we can get with these ones with Stable Diffusion. But this seems pretty good. The SDXL seems pretty good. So I'm gonna actually group the ones that are for DALL-E 3, so we have a reference. Actually, I found the other day, if I press here on download, the image actually now saves the prompt or the description. So it's much better because it saves the name contains the how can I see the entire name? Yeah, the name actually contains part of the prompt. And I think it also has a timestamp when it's saved, right? Not when it was created, but when it's saved. So let's save all of them like this. Right. Is it SDXL? Yeah, base model. All right. So yeah, so that works. GPT-4 is giving cinematic images. Yeah, it's really good. It's DALL-E 3 and GPT-4. Okay, so let's actually try. That was a bit of a diversion. Let's actually try now to go back to LoRa's training. We can look at that thing at some other point. Because I don't have too much time today, so not sure how much we're gonna be able to do. Okay, so where were we? Let's go back here. Ba, 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 integrated LoRa's. All right. Using LoRa for efficient stable diffusion fine tuning. Novel technique. LoRa for diffusers was initially proposed for language models. Yeah, so low-rank adaptation was contribution mainly by Microsoft and was first applied to models like GPT, like large language models, and it got applied then later to diffusion, image diffusion models. These here, the details of the following figure taken from the Stable Diffusion paper are not important. Just note that the yellow blocks are the ones in charge of building the relationship between image and text representation. Cross attention. So this thing here, denoising. Well, this thing says here that is taken from the Stable Diffusion paper. Okay, so that's the original paper. That's where I took it from. Okay. All right. Is this? Oh, okay. So this is the original Stable Diffusion paper. So Patrick Esser from Runway and the University. Okay. So I guess we can put this stuff in here. All right. Great. What else? Any other comments? So I have a hard problem pronouncing your name. I don't know if that's Greek or what is that, but I know V's on the chat and there's somebody else. So I'd appreciate if you tell me how that gets pronounced. That would be awesome. All right. So here I have, to the best of our knowledge, Simo Ryu was the first one to come up with a LoRA implementation adaptive to Stable Diffusion. Please do take a look at their GitHub project to see examples and lots of interesting discussion. In order to inject LoRA trainable matrices as deep in the model as in the cross attention layers, people used to need to hack the source code of diffusers in imaginative but fragile ways. Stable Diffusion has shown us one thing, it is that the community always comes up with ways to bend and adapt the models for creative purposes. And we love that. Providing the flexibility to manipulate the cross-attention layers could be beneficial for many other reasons, such as making it easier to adopt optimization techniques such as X-formers. Other creative projects, such as prompt-to-prompt, could do with some easy way to access those layers, so we decided to provide a general way for users to do it. We've been testing that pull request since late December and officially launched with our diffuser released yesterday. We've been working with clone of Simo to provide LoRa training support in diffusers, both for dream booth and full fine-tune methods. These techniques provide the following benefits. Training is much faster, as already discussed, compute requirements are lower, we could create a full fine-tune model. Blah, blah, blah. Train weights are much, much smaller, and this is what we talked about before. This is about 1,000 times smaller than the original size of the unit model. All right. We are particularly excited about the last point. In order for users to share their awesome fine-tune or dream booth models, they had to share a full copy of the final model. Other users that want to try them have to download the fine-tuned weights in their favorite UI, adding up to combined massive storage and download costs. As of today, there are about 1,000 Dream Booth models registered in the Dream Booth concepts library and probably many more not registered in the library. With LoRA, it is now possible to publish a single file, really small, to allow others to fine-tune your model. First person I heard use Dream Boothing as a verb in a normal conversation. Dream Booth more. Credit. Okay. LoRA fine-tuning. Full model fine-tuning of Stable Diffusion used to be slow and difficult, and that's part of the reason why lighter weight methods such as Dream Booth or texture inversion have become so popular. With LoRA, it is much easier to fine-tune a model on a custom dataset. Diffusers now provide LoRa fine-tuning script that can run in as low as 11 gigs of GPU RAM without resorting to tricks as 8-bit optimizers. This is how you'd use to fine-tune a model using Lambda Labs Pokemon dataset. All right, so here we got the code. We need our model name, our output directory, our hub model ID, our dataset name, an accelerated launch, blah, blah, blah. Full precision 16, train text to image with LoRa, blah, blah, blah. Okay. One thing of notice is that the learning rate is 1 to the minus 4th, much larger than the usual learning rate for regular fine-tuning model in order of blah, blah, blah. This is the previous one. We took about 4 hours. I did not attempt to optimize the hyperparameter, so feel free to try it out yourself. Sayak did another run on a T4. Here's his final model, and here's a demo space that uses it. For additional details on LoRa support in diffusers, please refer to our documentation. It will be kept up to date with the implementation. Inference. As we've discussed, One of the major advantages of LoRa, let me zoom in properly here. Actually, we can just leave it this way, right? One of the major advantages of LoRa is that you get excellent results by training orders of magnitudes less weights than the original model size. We designed an inference process that allows loading the original weights. Okay. That's important. All right. Gagging face. All right. Let's quote this guys here. Inference. Great. Where are you? Great. Okay. Anyone? Any comments? For those of you who are online, I don't remember, where are you guys connecting from? Like, I always mix up a bit the. Okay. Let's see. Oh, one thing I wanted to mention for those of you who are watching these live streams. I have a link at. Let me maybe make a slide. Luma.nono. Make it a bit smaller. Yeah, okay, that should work. So I'm gonna put this actually as a reminder in my slides. Maybe here. Yeah, maybe there. This here that I'm showing right now, or not yet. Yeah. So this link actually brings you to all the scheduled events that I have. It's free to RSVP and register. There might be events in the future that are not free or that might not be open. So you might be only able to RSVP and access through this link. So I would recommend you to subscribe, to go there and subscribe, and that way is the best way because it will send you notifications when I plan new events. So this says that it's live right now. I have scheduled these events, this one for next week and this one for the following, and it's like a centralized place where I can let others know what I'm planning, right? So this calendar, for example, if you look here, you can actually see what each day, what events we have, right? It's a pretty nice tool that actually I can use for free. You can also go and watch past events. So I'm trying to stay consistent with like Thursday streams. But yeah, so Luma, lu.ma/nono, and that brings you there. All right, let's see what else we got here. Okay, so yeah, let's keep going, making progress. There you go. Okay, so we got some of this code. So I'm looking here. So maybe the first thing is like to see if I can run some of these things on my computer. Let me look at Imaginary here. If they support LoRa's. No, doesn't seem like it. All right, let's keep going. This snippet will print the model he used for fine tuning. Base model. Model info. All right. Let's see. So from here, SD model fine tune LoRA T4. Right, as we saw last week, this is the checkpoint. Right, so this is kind of like the in-between steps of the process, but we have an easy way to download. So if I just grab the username and the repo name from here, I can go to my desktop and I could do Hugging Face CLI download from here, local directory. Where am I? The desktop. Okay. We just want to download this file. Let's try that. Oh, actually, it's downloading everything to that directory. So 1 sec. I think I need to put this before. Put the file. So basically, you put the Hugging Face CLI, the command is download, the repo, this one, and this is the file I want to download. And I put here local dir LoRA model, for example. And now it should just download that file. Yes. Okay. All right. So that's the weights. It's 3.3 megabytes in this case. And these are some results. These are checkpoints in case you wanted to continue training. And this is a demo space that uses it. Let's try to look at it. Oh, runtime error. Okay. Don't worry about that. So we have the weights, inference, LoRa weights. Yeah, I guess it downloads automatically. Let's actually go back to there. So the model that they have in files, they actually don't have any metadata. PyTorch LoRa weights. I guess they're always called PyTorch LoRa weights, and that's why you don't need to specify anything. Let's just try to run this. Let's see if I can run this locally. So I have a few environments already in here. So where is this? I cannot see the chat right now for some reason. Okay, back. Okay, so where do I have Hugging Face? I think Gemma, Conda activate Gemma. Let's try to run that example. Let's try to just run that code. So make their LoRA touch run model. Let's open this. All right, so we put this here. Let's try to see if this runs. Python run model. All right, that's pretty fast. And where did it download the model in the background, or? Okay. The snippet will print that, blah, blah, blah. In my case, I trained my model starting from version 1.5. So if you run the same code with my LoRA model, we just need to put this here. Okay. All right. Okay. So that's for blah, blah, blah. Model base. After we determine the base model we use, we load a normal Stable Diffusion pipeline. Right. What was the let me see if I can see here what was the I think for Google Gemma torch devices, MPS, that's our device. MPS MacBook Silicon. Let's try to see if this works. Diffusers doesn't exist, so I guess that won't work, but let's see, it might be okay. Pip install diffusers from Hugging Face. So that's the Hugging Face library in there. All right. All right. If you're watching this video, why don't you drop a comment on the live chat, or if you're watching offline later on the chat, on the comments of the video, what's some content or something that you liked or that you learned from this YouTube channel, right? From the videos that I've been making. It's really hard for me to get insights and get feedback on the things that you guys learn or do or want to watch. It's really hard for me. I just see numbers and stats and things like that. All right, so this is downloading a bunch of stuff. It seems like it's doing something that works because it seems like it's downloading model, and we would get an image supposedly. We're in this directory. I don't really know where that all is. Well, I know where it's being downloaded. So if we go to our cache from Hugging Face, we actually have this huge folder, 140 gigabytes, where I could delete a lot of this stuff. And these things that I asked for are here. Fine-tuned models, snapshot blobs, 142 gigabytes. We actually could delete some of these things, I guess, if I need memory in my machine. Right now, this downloaded runway stable diffusion 1.5. Da, da, da. All right. That's great. Okay, so what are we learning from here? I'm learning that it's pretty easy. I think it's really easy to run this code nowadays. I mean, another thing is that you understand it properly, that you know what's going on, what parts of the network are being, I mean, to know what parts of the network are being retrained, really, you need to understand the model architecture before. But yeah, so let's see, types of fine tune. So this is to train. All right, how much? So price of training SDXL in replicate. I like this representation of the tokens. So this could go with our tokenization content. Where is it? Okay, great. All right, so let's see how this did. All right, what's going on here? So this downloads, and then it tells us invalid arguments, model key is not a LoRA compatible conf or a compatible linear model. Model down blocks. Not that easy, not that fast. Let's see. So this was published on more than a year ago. So I'm not sure if this is completely up to date. Maybe we need to launch training. Let's see. Okay, so Google Colab. Let me see. So I want to see if we can train accelerate launch. It seems like this might be all that we need. Let's go to Colab. Let's go and take a look at Google Colab here and create a new notebook today. Okay, here's my question. So it takes 10 minutes, 15 minutes. So let's say it's 20 minutes. So it's gonna be 20 minutes by 60 seconds. So it might cost us less than a euro, less than $1 to. You can also download your fine-tuning weights use elsewhere. All right, so we can actually train. Let's go here again. All right, we might try that at some point. Let's see here. So we have live 100, fine tune, stable diffusion, LoRA. With LoRA. Okay, so let's copy this code here. Let's actually install pip install accelerate, make this appear, and choose GPU. So these guys here were saying A40. NVIDIA A40 GPU versus T4. All right, so let's install after we put the GPU on in this Colab notebook. Let's take a look really quickly. All right. Let me see. All right. There you go. Okay, it seems like that's ending. Let's see if we can model name output their dataset name. Have ID, have model ID, Pokemon LoRA. What I don't really know is that if we need to clone these things or these are all. Okay, let's take a look. Okay, so let's see if this starts training. Let's first see if this works, and then we can try, maybe next day we can try understanding all the inner workings of this. This here. Great, and I want to take a second to say hi to everyone who's watching this online or offline. Leave a comment on the chat and let us know where you're connecting from. And I would definitely invite you to subscribe and click on the bell if you want to get notified when I go live next or when I upload new videos. And give me a thumbs up if you're enjoying the content so far. I asked before a question for everyone who connects offline or online. What is something that you've learned in this channel, and what's something that you've enjoyed that you watched or that you learned? Okay, great. So this gave us an error. All right, so in this here, we actually need, let me get this out of the way. Okay. Okay, so we need to clone this repo. Do we, or we? Okay, let's actually just clone it. So we need to git clone this thing and then enter diffusers. Samples image. Right, so cloning there. Great, and if we were to ls, we see that we are in diffusers. Oh, okay. We gotta do this, I think. Let me try that. All right, there we are. Okay, so we would cd to content and then do this. Okay, let's do that. Okay, I'm just making sure. I go here, then here. Okay, go there. All right, we're in the right place. Okay, so great. Okay, so now we're on the right directory. So let's see what this does. If accelerate launch actually lets us train. All right, no model name datasets. Okay, so I guess I can do here cat requirements txt to see what things are there. All right, and we can actually do pip install requirements. Okay, we can actually see the requirements in here. All right, there you go. So we have accelerate. Okay, so I guess like we don't even we don't even need to run this by itself. I will run everything here. Everything's being collected and installed. And now, supposedly, now this should work, but one never runs out of errors. No model name diffusers. Okay. Pip install diffusers and run. One more try. All right, so we've been going for an hour now, and I think we've had enough. I think we're almost there. We might get it today, but we're gonna continue on this. I want to learn a bit more and try to do these examples. Like make sure that this example requires a source install from Hugging Face diffusers. Okay. All right, let's try this. Already everything. You're connected to GPU, but not utilizing GPU. Haha. I still want to keep it. Okay, installation, blah, blah, blah. What is this dot syntax? Hello, Mr. Jose Luis, Parametric Camp. How's it going? What are you doing today? How come you're coming by? All right. We're almost like at the end of the stream. I'm getting a bit tired of the whole day. But yeah, we've been looking at many different things. Many different things that I'm gathering information for, and that will probably record a bigger tutorial on really soon. I mean, we're kind of learning things from Stable Diffusion and fine-tuning many things here, and you're not seeing anything. I'm going to show you some of this stuff. Yep. So some of these things. Okay, let's see if that actually is working now. What are you up to, Jose Luis? All right. All right. Import error. Okay, report 2. Let's comment that one out. Okay, let's try this. All right. So the problem was that we don't have a weight and biases account set up there. Maybe we should. Maybe we should get one. Let me see if I have one. Okay, I don't think I have one. Let's see. Let's see what the pricing thing is here. Free personal, teams, enterprise, blah blah blah, academic research teams. Academic research teams. All right. Sign up. So let's actually okay. So I'm gonna leave this as a to-do. So we're gonna 1 dB. So let's put this for next stream, whenever that is. Let's put it for live 117. Sign up for weight and biases. Weights and biases, right? Yeah, okay. So this one gave us another error. No such file or directory. We have this command here, error number, make theirs. Train text to image LoRA. Line. File not found error. 439. 439. 439. Handle the repository creation. Fusers, examples. And I want to take a second to say hi to everyone who's on the chat. And I would really appreciate you say hi and let us know where you're connecting from today. Okay. Let's track pics to pics. All right. Texture inversion. Text to image. So if we double click here, we can actually edit this file in Colab, but note that it will get overwritten when we clone again. So these changes won't persist throughout sessions. We'll have to clone the repo or like do some manual stuff there. So we're gonna print here the args. Save. Let's rerun this cell. Okay. Okay, a completely unrelated question, as we saying, how do we host Llama C++ on a VM? VM, do you mean like a virtual machine like Docker, or like an actual computer? What operating system is running? I mean, it depends. Like Llama C++, I think, can run cross-platform in on Windows, Mac, or Linux. So you should be able to host it and run it anywhere really. But if what you want to do is make an API, I'm not sure. There might be a way to serve these models already as an API. I know Olama is a great way to run these models, and you can actually, as I saw there, you have Docker models, official Docker image, Azure virtual machine. Yeah, I'm not sure how you will do that. But I know that these guys are actually making it so you can recommend running Olama alongside Docker Desktop for macOS in order for Olama to enable GPU acceleration for models. Yeah, you could. It's maybe we can try Windows. Yeah, I'm not sure. I'll have to take a look at that, but not something that I've done. I'm curious now, like if I can just run this command here and have it running. So here we could add a marker for running Llama C++ on Docker, kind of like a diversion. Okay, so this seems like it's working, and it probably is working and downloading some of the models. So I'm not sure how that's gonna play with my network right now, but hopefully it doesn't interfere too much. Okay, so while this is downloading, I'm gonna leave this aside and I'm gonna keep going with this. So we printed, did we print something? Okay, it's not here where I want to take a look at errors, is here. Oh, okay. Yeah, that's right. So I actually was looking, yeah, I hate like when I put this camera, then many times I forget to switch to this and you don't see my screen. So yeah, I actually ran this command on my terminal. So to set up basically to create a container called Llama. And I can then run this command here and run it on the terminal. So let's see if that works. It keeps downloading stuff from there. Yeah, it seems like these two are synchronized. And I'm not sure if when this starts working, we'll be able to use a Llama through Docker. Basically Llama without having to Llama 2 without having to do anything on our machines. Okay, so this has no such file or directory. Four three nine 440. So now is this one. Handle the repository creation. Output there. Oh, it doesn't exist. Okay, so I think I don't even need to add any code here, I think. So I think the only thing we need is make their LoRA output. let's just put it this way. LoRA output. Oh, wow. Okay. Let's try that. I'm from Hyderabad, India. Okay, Hyderabad, India. I'll try to remember that. Hyderabad, India. I don't really know where that city is. Hyderabad, India. Right, I only been to this area here. It looks like a nice city. That's a lot of cables. Right. That's Hyderabad, India. Okay. What else is failing here? Make there is no such file. We're still seeing the same error. I've never run this one. All right, so now we should have here a directory called LoRA output. I'm gonna run the script, and I'm hoping that this is finally gonna work. Is that where the Kumela takes place? Jose Luis or parametric camp are asking. V. Okay, so honestly, I don't really know what's going on here. Okay, let's try one thing. All right, so this is actually not supporting my variables. Not sure. All right, so I think the problem is simply that these variables here are not being exported. So for now, I'm just gonna put these things here: model name, dataset name, and I'll put there. We already got that from the top. Have model ID. Have model ID. All right, so I'm gonna comment out these things because they don't work. I'm gonna try to run once more because this is gonna work now, hopefully. All right, not working. All right, token is required. You need to provide a token or be logged. Does this mean that it's trying to train remotely? Okay, who is asking me to log in? Token is required, right access action, but no token found. Oh, I see. So oof, biryani. That's great. I don't know what Charminar is. Okay, push to have. I don't want to push to have. So maybe that's Honestly, we're doing this through Python, so a Python notebook, so we might as well use the training syntax instead of this. But yeah, we'll have to do that. It seems like now this is working, it's doing something. Okay, to do turn this into a Python script that trains, not a terminal, not a bash command. Hopefully that's gonna work. Right. All right, I will once more. I see there's other people online now. Would really like if you say hi in the chat and let us know where you're connecting from and how you found us. All right, more errors here. So what happened here? On the hub or cannot be accessed. Okay. Let's go to Hugging Face, Lambda Labs, Pokemon Bleep captions. You need to agree to share your contact information to access this dataset. Oh, I see. Uh-huh. I guess that doesn't work. So we need another data set. Okay, so let's see. Are there other... Are there other models? Okay, so accelerate. So LoRA, fine tuning, accelerate, Hugging Face datasets. Let's see. I guess what we need to figure out is how to build our own dataset. So that's what sucks here because we don't have. Let me see. Let me see if with this link we actually get other dataset to see in what form we need to put the data. All right, so here, great. Yes, all right, so training script, the data set, processing code, and training loop are found in main. If you need to adapt the training script, this is where you'll make changes. As with the script parameters, a walkthrough of, let me put this here. So walkthrough of the training script is provided in the text to image training guide. Instead of this guide takes a look at the LoRa relevant parts of the script. So walkthrough of the training script provided in the text to image training guide. Let's see. Is this the same that we had? Oh no, okay. All right. So we actually walk through the training script. Okay. So we actually can take a look here. loads the unit, launch the script. Let's train on the Pokemon Bleep captions. All right, so which seems like it's not accessible. All right, so we got source dataset. All right, let's try to use this one, but at least here we can see the structure of different data sets. So of the actual data set. All right, let's try that one. Great. Yeah, what else? What else are you guys doing? So Jose Luis, what are you working on? V, what else are you working on outside of AI or what we're seeing here? What other projects are you taking a look at? Okay, this seems like it's doing something, and this data set here, so this let's take a look at the file. This has image and text. So we have a blue and white bird with its wings spread, a yellow and black Pokemon character, a yellow bird flying, a bird with a long beak flying through the air. Okay, so it's describing these things for the model. And okay, let's actually take a look at this and save this in our fine-tune slides. How to convert it to Parquet files. Dataset infos. Okay, so metadata about the dataset and then the data. All right, we need to see converted to Parquet. All right. All right, so I guess one thing that we need to do is how to prepare a data set. Prepare fine-tune LoRA Stable Diffusion dataset. And I guess at least here we have the training script and it's erroring again. All right. Okay, I'm gonna call it a day. I'm gonna try to look at this offline and attempting to unscale FP gradients. Attempting to unscale FP gradients. What is going on? So right when it starts training, it fails. CUDA, gradscaler. How much memory we have? We have 12 gigabytes of RAM. Let's Google that for one. All right, everyone's having the same error. All right, trying to debug here. Thanks a lot for the repo. Disappeared to fix it. All right, let's training. What do they do here? Let's actually see. Oh, mixed precision FP16 as well. So let's see what we have here. Same mixed precision FP16. Gradient accumulation steps 4. Gradient accumulation, blah blah blah. Efficient table. Once training, you can use your new train model. Yeah, right. Okay. All right. Okay. Multi GPU. Okay. Yeah, as I said, not gonna get anywhere today, I think. So we were taking a look at let's see at how to fine-tune Stable Diffusion. I think we did something, we learned a bit, and we got a bit to a good port. So I'm gonna close it up here. I'll say, let me see, what slides are these ones? All right. Yeah, I'll say thanks a lot to everyone who showed up today, who watches afterwards, and who was with us today. Hello V, hello Jose Luis, and other people that joined. I would invite you to join the community at Nono Martínez Discord. Remember that you can follow the latest events at lu.ma/nono, where I showed before. And yeah, thanks so much for watching. I'll see you next time. And don't forget to subscribe and click on the bell if you want to get notified when I go live next or when I load new videos. Bye.